Problem of the day today says a car starts out driving at 35 meters per second and accelerates up to 50 meters per second in 3 seconds. How far does the car drive in this time? All right, so as always, we will start with givens. What do we have for givens today?
We have the time, 3
Yeah.
seconds.
The time's 3 seconds, great, I-10. Delta T equals 3 seconds, good. What else do we have?
The VXI
Mm-hmm.
is 35 meter per second.
Right, 35 is our initial velocity, right? 35 meters per second, good.
Would 50 meters per second be the acceleration?
Let's see, would it be the acceleration? Somebody help her?
The final acceleration.
The final, not acceleration, right?
Velocity.
Velocity, yeah. But you can tell, right? It's meters per second, right? Meters per second is a speed. That's how far you go in a certain amount of time. If it was meters per second squared, right, or meters per second, then you have an acceleration, right? Acceleration is how quickly your velocity changes. So if you were unsure about whether that 50 was acceleration or velocity, the key is to always look at the unit, right? The unit can tell you whether it's velocity or acceleration. If it's going to be acceleration, it's always going to be meters per second squared. So it looks like we have our 3 givens. We've got delta T, we've got VXI, we've got VXF. We just need our unknown. Which symbol or which quantity are we looking for here?
Displacement.
Displacement, right, thank you, perfect. So the displacement or the delta X is what we need to find.
Displacement.
That's right, yeah. Thank you. Okay, great. So we've got our 3 givens and our unknown. We're looking for the displacement. We just need to pick the right equation, the equation that has delta T, VXI, VXF, and delta X in it. And who can tell me which equation that's going to be?
The first one?
Yeah, good, Angel. The first one, right? The first one's the only one that has these 4, right? Doesn't have, doesn't have acceleration, right? It's got the other ones, all the other ones. So delta X equals 1/2 of the initial plus the final velocity, and then times time. All right, so step 4 would be to rearrange our equation to get our unknown all by itself, but we're in luck today, right? Delta X is the unknown, and delta X is already by itself, so no algebra today. We can go ahead and plug our numbers in. So we have to do 1/2 times 35 meters per second plus
50.
Yeah, plus 50 meters per second, and then we'll multiply all that times 3 seconds for time. And we want to make sure we use the parentheses here on the calculator, right? Because we do 1/2, so 0.5 times 35 plus 50. We'll close the parentheses and multiply by 3. And I get, looks like 127.5. And the units I get, right, these are meters per second here. And if I multiply that by seconds, the seconds cancel out and I just have meters. I was looking for displacement. So meters is a sensible unit to get. That's the unit, the SI unit for displacement. And 127 meters, that seems like a reasonable distance to go in 3 seconds if you're going, between 30 and 50 meters per second. Any questions on how we got that one today? Okay.